Hey everyone, have you ever wondered why accurate measurements are so crucial in science? Today I'm going to break down the science of accurate measurements and how you can get them just right using standard units. Let's dive in. First off, why do measurements matter so much? Imagine trying to bake a cake without measuring the ingredients. Total chaos, right? The same goes for science. Accurate measurements ensure that experiments are reliable and results can be replicated by anyone, anywhere. So, how do we make sure our measurements are precise? It starts with using standard units. You might already know the basics: meters for length, kilograms for mass, and seconds for time. But there's more to it. For example, temperature is measured in Kelvin or Celsius and electric current in amperes. These standardized units help scientists speak the same language, no matter where they're from. Now let's talk about the tools. For length, you might use a ruler, a measuring tape, or even a laser distance measurer. For mass, a digital scale or a balance. And for time, a stopwatch or a timer. Each tool has its own level of precision, so choosing the right one is key. But here's the kicker: just having the right tools isn't enough. You need to know how to use them correctly. For instance, always read the measurement at eye level to avoid parallax error, and make sure the tools are calibrated and zeroed out before you start. Once you've got your measurements, it's time to organize the data. This is where a lot of students get tripped up, but it's easier than you think. Start by creating a data table. Label your columns with the physical quantities you're measuring and their units. Keep your data neat and consistent. This will make it easier to see patterns and draw conclusions. Another tip: always take multiple measurements and calculate the average. This helps to reduce random errors and gives you a more accurate result. Plus, it looks super professional in your lab report. And speaking of lab reports, don't forget to include uncertainty. No measurement is perfect, and acknowledging the uncertainty shows that you understand the limitations of your tools and methods. In summary, accurate measurements are the backbone of scientific investigations. By using standard units, the right tools, and organizing your data carefully, you can make sure your experiments are spot on. Remember, precision is key. Thanks for watching. If you found this video helpful, give it a thumbs up and subscribe for more science tips. Keep exploring, stay curious, and I'll see you next time.